This is a solution video for question 15 of paper 2 from the TMUA 2020 exam. So the question here is about finding necessary and sufficient conditions for this to be true. So we want the sum of sine of k pi over 3 from k equals 1 to some number n to be equal to square root of 3 over 2. And we want necessary and sufficient conditions on n. And we're given a bunch of conditions here, and we need to figure out which one is actually necessary and sufficient condition for this to be true. So the first thing to try and figure out is, what does this sum look like? So we want this sum to sort of become square root of 3 over 2. So it makes sense that after n increases large enough, then the sum will sort of be periodic about n. So let's first try and figure out what this sum looks like for some values of n. And in order to do that, we're going to have to figure out what is the value of sine of k pi for some values of k. So I've drawn up a table here. Essentially, we've got a table with k equals 1 up to 8, and then we've got k pi over 3, which is our argument here, and sine of k pi over 3. So when k equals 1, we've got k pi over 3 just being pi over 3, and sine of pi over 3 is just square root of 3 over 2. You should recall that from your 30, 60, 90 triangle. And if you look at the triangle here, so 30, 60, 90 triangle has these side length. So sine of pi over 3 is just going to be square root of 3 over 2, because sine of pi over 3 is just sine of 60. Okay, so next, if we move on to try and find sine of k pi over 3 when k equals 2, so sine of 2 pi over 3, then this should be the same as sine of pi over 3, because 2 pi over 3 is the same as pi minus pi over 3. So that means that sine of 2k pi over 2 pi over 3 is square root of 3 over 2 as well. Or you could try and use like addition angle formula and so on to figure it out. And then sine of pi, that's when k equals 3, is 0. Sine of 4 pi over 3 is going to be minus square root of 3 over 2. And sine of 5 pi over 3 is going to be minus square root of 3 over 2 again. So if you do not know these values, then you could draw up the following diagram. So in this diagram here, for example, so this line here is when this angle is 2 pi over 3. So that means that sine of 2 pi over 3 is going to be square root of 3 over 2, because it's going to be sine of this angle. Now if we look at this line here, so that's sine of pi plus pi over 3, so that's sine of 4 pi over 3, and it's going to be minus square root of 3 over 2 because it's in the third quadrant. And similarly for sine of 5 pi over 3, which is this line here, so this angle is going to be negative square root of 3 over 2 again, because it's in the fourth quadrant, and sine is only positive in the first and second quadrants. Okay, so now, once we've got these tables, we can realize that after this point, so after we reached the value k equals 6, then we're just going to repeat ourselves, because then k pi over 3 would have turned to 2 pi, then to 7 pi over 3, and so on, which is just this plus 2 pi. So we're repeating itself because sine is periodic. So now if we look at these values, we want to figure out, okay, when is this sum equal to square root of 3 over 2? So if I take n equals 1, then it's clearly true. Next, if I take n equals 2, then I'm going to get square root of 3 over 2 plus square root of 3 over 2, which would be square root of 3, which is not that. If I take n equals 3, I would get the same thing that I would have gotten if I took n equals 2. And if I take n equals 4, though, I would get square root of 3 over 2 plus square root of 3 over 2 minus square root of 3 over 2. So these two would cancel out, and I'll get square root of 3 over 2 again. So that means for n equals 4, it works. Similarly, you can see that for n equals 7, it also works, because then it repeats itself after this point. So when I have 7 here, the value here would be square root of 3 over 2. Then if I add everything up, this would cancel with this one, and this one would cancel with this one, and the only one that would not be cancelled out would be the last one here, the square root of 3 over 2. So 7 also works. So we can see that this pattern is going to repeat itself, so it's going to be every time with 1 more than a multiple of 3. Therefore, the answer is going to be D. So the answer is D.